Sir, we know you are the principal architect for Aadhaar and you have built a megawatt data center. When I say data center, do you really need megawatt of power?
I think you don't need megawatt for everything. It depends on the workload, right? So we have demonstrated that you can actually build in kilowatts. Again, depending on everybody doesn't require megawatt. You can also build in kilowatts, right? Yeah.
So in Mysore, if I have a small industrial land, can I build a small data center using kilowatt and all the technology?
Yes, very much possible today.
So namaste.
Okay.
I am Vijayanand Gurudev. Let us welcome Srinivas Varadarajan, founder and CEO of Vigan Labs. Today we are here to conduct 4 sessions on mythbusters surrounding data center operations. Sir, shall we begin?
Yes, sir.
Yeah. The first section is on data center power consumption, myth versus fact. I will ask a question and you could give your answer.
Okay.
So, as you are aware, Srinivas Varadarajan is running a micro data center in Mysore since 2020, and over the past 6 years, they have worked extensively on power utilization, power consumption, AC, cooling, optimization, and also on several other aspects of cyber security, high performance compute, and things like that. So, with this, sir, first let us work on the data center power part of it, consumption. The first question is, does turning off idle servers always save significant power?
Again, see, very depends, right? You can't simply turn off server just like that. There'll be a workload coming in, right? Workload coming in. Traditionally, most of the business applications you run in data centers are 24/7, right? You can't simply shut down a server, okay? So to shut down a server, you have to move the workload to a different server, right? As long as you have capacity. So you need to do the trade-off. See, it's worth moving the workload to some other server, and finally it's a simple math, right? How much does the server consume? Idle server power consume?
Okay.
Then can I move the workload to another server? What's the impact there? And what's the effort of saving it? Because once you move the workload, shut down the server, shutting down consumes some energy, bringing up also consume energy. I have to move it back again. So you need to look at the overall economics of energy and do that. Not only the energy consumption, it will also cooling, right? You move the workload from one server to another. Let's say server 1 is in rack 1. You move the workload from server 1 to server 2, right? In another rack. Your thermal workloading there. So you need to look at the overall perspective and then take a decision. It's not so simple as we think, right?
Yeah. Sir, moving on to the second question. Is cooling responsible for more power consumption than IT equipment in modern data center?
Not exactly. See, cooling, consumes about 50%, right? On average, about 50% in the data centers today. So the IT load consumes 100 units of power. Cooling consumes 50%, 50-60% of power, right? 50%. I would say 50% is a fair number, right? Yeah.
Sir, does increasing server utilization always increase total energy consumption proportionately?
See, so increasing server utilization will increase the consumption, right? Because what you are doing is you are running the the CPU at higher frequency. You are using more cores, right? Suddenly increase, but it may not be exactly linear. Again, depends on because server is composed of CPU, memory, IO, right? There are many parameters. So again, look at the workload, and as a general thumb rule is, as you increase the utilization, your energy consumption increases.
So it is directly proportional to energy efficiency per workload. So
Sort of,
Sort of. Okay. Sir, can reducing PUE, power utilization efficiency, alone guarantee an energy efficient data center?
PU is one of the many metrics, right, used to measure data center efficiency, but not the best, but one metric. So PU will tell you how efficient your electrical systems are there, how efficient is your cooling systems. Okay. But PU never measures the efficiency of your IT systems.
Okay. Are new servers always more energy efficient than the older ones?
See what's happening in the server industry today, right? The silicon technology improving, right? As example, number of transistors which you can pack in a given area is increasing. Let's say we had a long back, we had 10 nanometer, we went to 7 nanometer, 5 nanometer, 2 nanometer, we're talking. As you decrease the nanometer silicon, the amount of transistors you can pack in a given area is increasing, right? So proportionally, the amount of energy consumed per unit of power is the amount of energy consumed per work done is getting reduced over time, right?
Okay. So it is basically the density of transistors is what you're saying.
Yes, yeah.
Okay. Does virtualization reduce power consumption?
Again, depends on what I said. What is virtualization doing? Right? Virtualization allows you to pack more. See, as you get bigger and bigger servers, right? Bigger and bigger servers. Let's say today you have got 120 core, 128 core, 190 core CPUs, right? You can put 2 of them. You have hundreds of cores in a server. Very hard to find a single workload other than HPC workload to use all the cores, right? So what you do is you slice the server capacity into multiple virtual machines, right? So instead of using 10 low capacity servers, probably I can replace one server with low capacity, one bigger server with a higher capacity. So we're actually consolidating the workload from many physical servers into one large server. So you save space, save power too, right?
And also cooling.
Cooling, yes. You instead of cooling 10 servers, you probably cool one server, but you are increasing the density of energy, right? It's not that the energy consumption is going to become 1/10.
Correct.
It's probably higher than 1/10, right?
Okay. Sir, we have these two words, power and energy.
Yeah.
We use it very casually. Power is kilowatt,
Yeah.
whereas energy is kilowatt hour.
Yeah.
So, is power consumption the same as energy consumption?
See, power is instantaneous, right? How much is the current or voltage is currently emitting, right? So energy consumption can vary over time.
Anyway,
See, example in a given, let's take an AC, right? AC, right? You have 220 volt single phase power. Current can vary from 10 amps to 15 amps over time or less than that. So energy is the power is as a function of time is equal to energy, right? So we say simple DC V equal to power equal to V into I, right?
V into
when
I,
it comes
VI.
to AC, V is basically voltage into current into phase, right? So
phase.
basically you take the area of the curve, right? And that's what the energy.
Area under the curve.
Energy is the power consumed over time.
Correct. Okay. So we also know that we get power supply through AC, through the grid. Through transformer it comes, then it steps down, then it comes in AC. Then we store it into batteries, into DC. And again use inverters to convert back your pure DC into pure sine wave or pure AC, and then supply it to the computers or the servers. And servers again using SMPS they convert into DC. So there is a sufficient energy loss across all this energy conversion and in the entire system. So do high efficiency UPS system significantly reduce energy losses?
See, there are state-of-the-art UPS systems today which are highly efficient, right? Again, highly efficient, high utilization, right? So they do reduce the losses, significantly. And today, I think still predominantly data centers are AC based on, right? Because the majority equipment available in the market is predominantly AC. That's why people use AC in data centers, right? And there's work going on creating DC, right? The new standards are coming.
Okay.
Eventually, over a few years down the line, we'll have probably a lot more DC equipment available, and people will probably switch over to DC.
Okay. So will AI workload always consume dramatically more power than the traditional workload?
See, traditional workload, just look at a traditional workload. A server used to consume, half a kilowatt to 1 kilowatt of power in a single server. A similar server, probably you put a AI workload use GPUs, right? What is a GPU? A large number of silicon packed in a small area, right? It's basically symmetric multiprocessing, right? SIMD instruction set. You package a lot of them. So GPUs consume a lot more power than a traditional CPU, right?
Okay.
A single server which used to consume, let's say half a kilowatt of power. Let's say you put eight GPUs, high-end GPUs today. You will end up consuming 5 to 10 kilowatt of power.
5 to 10 kilowatt power. And also it increases the cooling.
Because you need more cooling.
More
right?
cooling.
You need more cooling for the same server.
Okay. So we are now entering into the cooling phase. Is free cooling only useful in cold climates?
See, not just cold climate, right? Look at the globally, right? Even look at any country, tropical region, right? There will be time of the day when the temperature is cooler outside. So winter example in a city like Mysore, winter night time is around 18 degrees centigrade.
Correct.
So whenever you have the outside temperature much lower, you can probably use free cooling for it.
So Vigan Labs has used this.
We use free
technique.
cooling, right?
Yes.
Yeah.
Sir, now moving on to the rack density. Does increasing rack density always increase total facility power consumption?
Of course, see, rack density traditional workloads used to have 5 to 10 kilowatt of power. As AI coming in, we are doing 30 kilowatt, 100 kilowatt and beyond, right? It's now becoming hundreds of kilowatt. Of course, so if let's say 10 racks, each used to take 10 kilowatt earlier, your total workload was 100 kilowatt.
100 kilowatt.
Now each rack takes 100 kilowatt. Within 10 racks, you can consume megawatt, right?
A megawatt of
so
power.
You're increasing the energy consumption by order of magnitude, right?
Correct. Sir, now since we are now already in megawatt, are renewable power data centers completely carbon neutral?
Again, renewable, see, let's say, I said 10 rack data center consume a megawatt, right? To generate a megawatt of power, you need a amount of space. Today, let's take a solar, right? Solar, right? So 1 megawatt, 1 megawatt. See, solar is not available throughout the day.
Correct.
You get 4 to 5 hours a day, you can generate power.
And it is
So
not
if I
throughout
put
the season.
let's take a 1 megawatt data center, per day you consume 24 megawatt hour of energy. What is the energy, what is the solar panel required to generate 25 megawatt, right? So 1 megawatt of solar panel, you can generate 5 megawatt of power. So 1 megawatt requires 2.5 acres of land. So 24 megawatt of power, you need 5 megawatt of solar panels, which means you need 15 acres of land. So that's a big issue, right? You need a huge amount of land to generate energy And you have to store it, right?
Store
Not
it.
just energy,
Battery is again
Battery. So
another
daytime
challenge.
you need to store energy, you need a battery system. Yes. So I think if you have enough space, land is not an issue. You can still, completely do renewable, maybe a combination of, solar plus wind, right? And of course with battery storage.
So we need to adapt all the available sustainable
Yes,
sources of
yeah.
energy. Okay, moving to airflow management. Can better airflow management reduce cooling energy without changing IT equipment?
Yes. See, basically, what is the purpose of airflow is to take the heat out of the servers, right? So we improve basically the faster you take out the heat of the server, the CPUs don't get hot, right? So better air circulation, better airflow, right? You need to calculate how much of CFM energy, how much of air you need, right? Air volume you need to take the heat out of the servers. So you have a proper airflow management. You can run the servers very efficiently, right?
Okay. So does every watt consumed by IT equipment eventually become heat?
So more than 50% gets converted to heat, right? Because when you have a transistor, there is resistance, right?
I square R loss.
See, go back to the fundamentals of math, right? Work requires energy. Doing energy requires overcoming resistance,
Overcome
right? Could be
resistance,
physical and electronic.
You are trying
Everything,
to-
every work in the world, even magnetic, there is a resistance.
and
When you
also
overcome resistance, there is a friction, electrical, electronic, and you generate heat, right?
and if you reduce the nanometer size,
Yeah.
it is increasing the resistance as well. So the
Yeah,
more and
so-
more compact the things, it will generate more heat.
So basically, the more compact you make, you are generating more heat in the small area, right?
Yeah.
And it becomes a challenge.
Challenge.
How do you take heat out of the small area?
Small
right?
area. So it is isolation of heat basically.
That's right.
which
So
we
how
need
quickly
to-
you can take the heat out of the system?
Okay.
The challenge today.
Okay. So sir, with this we come to the end of our first session on power consumption and its related thing.